Now, let's use the mathematical equations to prove the relationship of volume and temperature that we discussed about Charles' law. So, Charles' law states that if the pressure is held constant, the volume of a given amount of gas is directly proportional to its pressure. Or, as the temperature increases, the volume will also increase, and as the temperature decreases, the volume decreases. Now, to move on to our discussion for today, you will need a calculator. Volume and temperature are directly proportional to each other, and because of this one, we will give us this equation wherein volume is equals to the temperature at constant pressure and number of moles. V, capital Victory, is the volume, capital T is the temperature, capital P is the pressure, while small letter n is the number of moles. Now, because we have volume and temperature, and that is constant, we will have a symbol of K to represent the proportionality constant between volume and temperature. Now, to get the equation for the relationship of volume and temperature, we need to divide both sides to temperature, so then we will have this one wherein it is constant that volume is directly proportional to the pressure. So if we have a directly proportional relationship between volume and temperature, it is always equals if there is a change happen to them. So the relationship between volume and pressure is still the same, although there is a change between them. Now, to get the equation, if one quantity is unknown on a given word problem, we need to divide or to cross multiply the equation to give us this one. So initial volume and final temperature is always equals to the product of the final volume and initial temperature. Now let's use this equation on a word problem. Remember to use GRESA or GRESA. G is for the given quantity on a word problem. Always indicate the unit. R is the required or the unknown. E is the equation or the formula to be used. S is the solution, and A is for the answer. It should have a unit as always. Now, let's use GRESA and the equation for Charles' law to identify the unknown quantity. So let's say we have an inflated balloon with a volume of 0.75 liter at 30 degrees Celsius, and it was placed inside the freezer when temperature is negative 10 degrees Celsius. Find out what will happen to the volume of the balloon if the pressure remains constant. Support your answer with computation. So first, let's use the GRESA. Let's first identify the given. So on the given, we have the initial volume, which is 0.75 liters, and a temperature of 30 degrees Celsius. Always remember to use the temperature scale Kelvin. It is because it has the what we call the absolute zero, wherein a motor do not have an energy at all. So all the temperature to be used on Charles' law should be converted into Kelvin. So to convert Celsius into Kelvin, we need to add an additional of 273.5 into Celsius to get the Kelvin. So if we have an initial temperature of 30 degrees Celsius, we need to add it to 273.5 to get its corresponding amount in Kelvin scale, which is 303.5 Kelvin. So we have the initial temperature of 303.5 Kelvin. Next one, we also have the final temperature, which is the negative 10 degrees Celsius. Now we need to convert it into Kelvin. So we need to add negative 10 degrees Celsius into 273.5 to get the Kelvin amount of negative 10 degrees Celsius, and that would be 263.5 Kelvin. So our final temperature is 263.5 Kelvin. So now we have the following quantities, and now let's identify the required or unknown quantity among the four, and that would be the final volume. So the one that is being unknown on this word problem is the final volume. Now to get the equation for this word problem, we need to divide again both sides of the equal to the quantity beside the unknown one. So the unknown is final volume and the quantity beside it is the initial temperature. So we need to divide both sides into the initial temperature to cancel out the initial temperature on one side of the equal and left the unknown one, which is the final volume. So the equation we have for this word problem is this one. So final volume is equals to the initial or the product of the initial volume and final temperature over or divide it by the initial temperature. Now let's put it on a solution. So final volume is equals to the product of initial volume and final temperature. So initial volume is 0.75 liters, while final temperature is 263.5 Kelvin. So first we need to multiply or to get the product of these two, and we will have 197.625 liter Kelvin. Then we need to divide it into our initial temperature, which is 303.5 Kelvin, and we will have 0.65 liter as the final volume. Now, why we have liter? It is because we need to cancel out the Kelvin and we will left the Kelvin unit, and also liter is a unit for a volume. Now, let's identify what happens to volume and temperature after the change. So for volume, initially we have 0.75 liter, and as a final amount or quantity for volume after change, we have 0.65 liter. Now as you can see, from 0.75 to 0.65, the volume decreases. How about the temperature? So initially we have 303.5 Kelvin for the temperature, and it changes into 263.5 Kelvin. So as you can see, from 303.5 to 263.5, the temperature also decreases. So Charles states that at a constant pressure, volume is directly proportional to temperature. So as the volume decreases, the temperature will also decrease. Now let's have another example. So let's say we have a cylinder with a movable piston contains 253 cubic centimeter air at 10 degrees Celsius. If the pressure is kept constant, at what temperature would you expect the volume to be at 150 cubic centimeter? So first, let's identify the following givens. So first, we have the 250 cubic centimeter as the initial volume. Next one, we have the temperature. So we have 10 degrees Celsius. Then we need to convert it into Kelvin. So we need to add 273.5 for us to get the 283.5 Kelvin as the temperature. Then last one, we have the 150 cubic centimeter as the final volume. So we have the initial volume, initial temperature, and the final volume. And the one that is unknown on this word problem is the final temperature. When is the temperature would be if there's a change on the volume. So the required or unknown is the final temperature. Now to get the final temperature, we need to divide both sides of the equation into the quantity beside it, and that is the initial volume. So we need to divide both sides of the equal to initial volume, so that initial volume will be cancelled on one side of the equal, and final temperature would be left to get this equation. So final temperature is equal to the product of final volume and initial temperature, divide it by the initial volume. Now let's put the quantities into the solution. So we have the 150 cubic centimeter as the final volume and 283.5 as the initial temperature, and 250 cubic centimeter as the initial volume. So first, let's get the product of final volume and initial temperature, and we will have 42,525 cubic centimeter Kelvin, and we need to divide these two to have an answer of 170.1 Kelvin. Now we have this unit Kelvin because we need to cancel out the cubic centimeter and we will left the Kelvin. So this is the final temperature. Now what will happen to volume and temperature after the change? So let's say we have first the volume. So volume initially have 50 cubic centimeter, and after a change it has 150 cubic centimeter. So as you can see, from 250 to 150, the volume decreases. Now for temperature, from 283.5 Kelvin, it changes into 170.1 Kelvin. So as you can see, from 283.5 into 170.1 Kelvin, the temperature decreases. So Charles states that as the temperature and as the volume decreases, the temperature will also decreases, or they are directly proportional to one another. So that's it for the Charles law. So now for your task, answer the LM Unit 4 word problem on page 368. Use Carissa in answering. Here are the problems. So a cylinder with a movable piston contains 250 cubic centimeter air at 10 degrees Celsius. If the pressure is kept constant, at what temperature would you expect the volume to be? 150 cubic centimeter. Number 2. A tank, not rigid, contains 2.3 liter of helium gas at 25 degrees Celsius. What will be the volume of the tank after heating it and its content to 40 degrees Celsius temperature at constant pressure? And number 3, at 20 degrees Celsius, the volume of chlorine gas is 15 cubic decimeter. Compute for the resulting volume is that if the temperature is adjusted to 318 Kelvin. So as you can see, we have two different units for the temperature. So always convert Celsius into Kelvin. Then provide that the pressure remains the same. Now if there's no more questions about this lesson, you can now proceed to your activity. Thank you very much.